Hello, my dear friends, fellow pilots. I'm sure some of you must have been regularly following my numericals lessons and also doing them. Just having a look at them will not be advisable. At the end of each question, I have started giving you some numericals also for practice. Do it for your own benefit. And occasionally, some of you can sit down together and help out or check out each other's mistakes. And at the end, I'm also giving you answers to those questions. If you're liking my videos, don't forget to like and subscribe also. And also share it with your friends so that more and more people can benefit from my effort. Now, here in today's lesson, we will cover what is earlier known as a point of no return, and now it is called a point of safe return. It is also called radius of action, PNR, PSR, or ROA. Most commonly still being used is even PNR, right? It's a point farthest away from your home base on a particular track to which aircraft can fly and return to home base within safe endurance. Endurance is the time an aircraft can fly within a given fuel. It can be in hours, minutes. Safe endurance is without using your own reserves. What is the requirement? Let's say this is your departure station, and a ship en route on this track is reported in trouble or missing or out of contact, and you are launched to search for that ship on that route. Fine. Now, you have to make sure that in your enthusiasm to look for the ship, don't cross this point of safe return. Okay. This is a point you must turn back towards departure, back to departure, so that you are back here. And in case there is a requirement to divert or hold, you have your reserve fuel with you. They would head to launch another aircraft to search for your aircraft. So, please remember, most important point is that do not use your own reserves. And the PSR fuel which I can use is total fuel on board. If I have surplus, go ahead and use it, including surplus if any. Otherwise, it will be the flight fuel. Total fuel on board minus reserve fuel. So that means, in other words, flight fuel, and if you have a surplus, by all means, go ahead and use it. The reserve fuel will be mentioned for a particular period, that save a reserve for 1 hour, 2 hours, etc. Then all that you do is from the total fuel, subtract that fuel for 1 hour, 2 hours as required for your reserve, or it may be given as percentage of flight fuel. For example, that reserve is 10% of flight fuel. In such a case, I have to calculate flight fuel. What flight fuel I can use? So here, it is fuel on board. If reserve is 10% divided by 1.1, 20% reserve divided by 1.2. And the reserve is always for a flight fuel and not of the fuel on board. Fuel on board is the end figure, including reserves. So once you have calculated the fuel available for your flight, then find out the endurance. How long can I fly? This endurance is also called safe endurance. PSR fuel divided by the fuel consumption and leave it in hours or decimals hours. No need to convert into minutes. So in case you calculate that your PSR fuel available is 2,650 gallons, and the consumption is 300 gallons per hour. So 8 point divided, and that will be your answer. 8 point so many hours. Usually up to second decimal should be fine. You may round off the third decimal. Otherwise, your question will unnecessarily become too long on the calculator. Now, how do I calculate this point? Your total endurance, which you have, in this you have to fly outbound, also return home in this particular time. So this will be time outbound. That is this distance r divided by my ground speed outbound, plus the time you will take inbound, same distance r divided by my ground speed on the return, that is home ground speed. Then the value of r, also called dPSR, is EOH over O plus H. And time to PSR will be EH over O plus H, or this distance R divided by O. When I divide this by O, it remains EH over O plus H. Or once you have calculated R divided by my ground speed outbound, I will know that on my outbound flight, this is the time I should turn back. So in this question, step number 1, calculate your ground speed outbound and home on the return route. If outbound is tailwind, return will be in headwind conditions. Find out values of ground speed O and H and calculate the PSR endurance in hours, PSR fuel divided by the fuel consumption per hour. Now let's say, example, total fuel on board is 9,000, fuel consumption is 800 kgs per hour, and you're told to keep a reserve fuel of 1 hour. Okay. So 1 hour, 800 kg is gone. So my PNR fuel now will be, PNR or PSR fuel will be 8,200 kgs. And I have also calculated outspeed ground and home ground speed. And in this question, it is given to you, so that saves my time. So your distance to PNR will be E endurance into ground speed outbound into ground speed home divided by O plus H. And your answer will be 1015 nautical miles, and time to PNR will be this 1015 nautical miles divided by ground speed outbound of 224.61 hours or 4 hours 37 minutes. Multiply decimal of hours with 60 and you get minutes, or go to your nav calculator. Now, what if your engine fails? Okay. And you are outbound and your engine fails, then what should you do? Should you go to the same point or come back? We'll do it little later. Now, few points to remember are that your distance to this PSR point is primarily dependent only on fuel. If your fuel increases by 20%, the distance which you calculated originally will also increase by 20%. PSR is also proportional to fuel efficiency or inversely proportional to fuel consumption. If the fuel consumption, actual fuel consumption in the flight is less, your 10% less, your fuel efficiency will be 10% better, and PSR will also increase by 10%. Now, If you have calculated the DPSR with the headwind conditions given to you by the MAT, but maybe you applied it wrong by mistake, or you find the actual winds are tailwinds of the same strength, then what will happen? Your DPSR will remain same. Your O will become H will become O now, and O plus H. DPSR will remain same, but time to PSR, R divided by the ground speed outbound will now change. So time to PNR will change. These are theory questions as well as numericals. And maximum DPSR calculated is always under nil wind conditions. In any wind conditions, you will find that your DPSR value will be less than the one that you calculate with nil winds. That means your true airspeed itself is your ground speed. Okay. We will do a few numericals later on. Now, what if my engine fails? Then what do I do? If I have an engine failure, the worst case is that I have an engine failure. I've already reached my PSR and now I have an engine failure. Now, take a note. You must know that when an aircraft has an engine failure or pressurization failure, it has to change its flight level, or you have to change your flight level. The true airspeed as well as fuel consumption will change. Now the endurance, I cannot calculate with the original consumption on all engines. Now to solve it, there is a slightly different method. Fuel available for PNR, write down fuel, is equal to fuel used per nautical mile outbound on normal power plus B, fuel used per nautical mile inbound on reduced power. Assuming the problem occurs at the end and you to return all the way on reduced power. And here it is, should be single U, correct it. Now the question can be solved that R, distance to PNR in nautical miles, will be equal to PNR fuel divided by A plus B. So first calculate A, fuel consumption divided by ground speed outbound. Then calculate B, fuel consumptions reduced on the return divided by the ground speed reduced. So this will give you the fuel per nautical mile on reduced power. So fuel available divided by A plus B will give you the value of R in such a case. And time to PNR will be this distance R divided with my normal ground speed outbound with which I have been flying. And in case your engine fails before your PNR, you could turn back from there itself. Okay? Or in any case, even if you go to the PSR, still you can come back, but now you are on single power. So your fuel consumption will change. So generally the procedure is that if your engine fails on the outbound, return. So in your questions on critical points, we used both the values of O and H reduced. Here, only the home ground speed is taken as reduced and outbound ground speed is normal O. We don't even calculate the reduced O, not required. To calculate the PNR fuel available, if the reserve given to you is for 1 hour or 2 hours, then reduce your fuel by 1 hour or 2 hours at the normal rate. Okay. But in this case, the total fuel available, in case you are coming back on reserve power, then it will be the fuel on board minus reserves for 1 hour or 2 hours, whatever you are required to maintain on reduced power. Because we are now coming back on reduced power, if we have to hold, this will be your fuel consumption on reduced fuel consumption. Now, when you are given normal numericals also, he says go and outbound on normal power, the PSR will be different. And if he says come back on the reduced power, then we will follow this method. R is equal to PNR fuel divided by A plus B. Here is an example. PNR fuel is 6,000 US gallons. Fuel consumption normal is 1,000 USD per hour. Reduced is 800 USD per hour. Normal ground speed outbound is 490, calculated with the reduced ES on the inbound. Okay, with the winds now, headwinds will change to tailwinds, and if outbound was port drift, inbound will be starboard drift. And calculate reduced ground speed inbound, then it will be 1,000. Oh, sorry, fuel available. I beg your pardon. Fuel available is 6,000. Here I need to correct it. I forgot to correct it. I had earlier planned this question with 10,000 kgs and then changed it to 6,000 kgs and forgot to change this figure. Okay. So PNR fuel is 6,000 divided by value of A, fuel consumption by ground speed outbound. And on the way back, reduced fuel consumption divided by the reduced ground speed. And I will get the value of R, in this case, 1504 nautical miles. And time to PNR will be this distance divided by the normal ground speed outbound with which I've been flying, 3 hours, 7 minutes, 07 hours, 3 point, which is 3 hours and 4 minutes. Okay. So this is the way I will solve this question. Now, as usual, you can practice a few numericals. Here they are. I will extend this lesson by another 5-7 minutes. You can take a pause, note down these questions and give the answers. First question, true speed, wind velocity, find out ground speed out and home on track 200. Okay. Fuel consumption outbound is 2850, home is 2680. So I will have to use the second method. And fuel on board is 12,000, including 2,000 reserve. So fuel available for my use will only be 10,000 kgs. Find PSR. So I will use the second method. Going outbound, fuel consumption is different. On return, fuel consumption is different. Question number 2. PNR fuel has increased. Find out by what percentage. Increase your distance by the same percentage. And question number 4 is similar. He says fuel consumption was 200, but actual is more. So how much percentage more? That much percentage less will be your now new PNR. Question number 3. Fuel on board 2,200, including 10% of flight fuel as reserve. So if your flight fuel is X, X plus 10% of X is 2,200. Find out the value of X and use that as your PNR fuel. Do it yourself, and I've given you the answers. If you find any of these questions difficult in your comments, do mention that I had problem in this question and I'll come back to you. But I've explained you all these concepts, so try and do it yourself. And here, fairly simple, distance A to B 500, track, wind velocity, true speed is given to you, safe endurance is also given to you. Calculate DPNR and TPNR. Try these 5 questions. They are all different questions. So I have tried to concentrate on quality and maybe not the quantity. Any number of books are available in the market. Now, if you can do these 4-5 questions, you'll be able to do all the questions from different books. Okay, and some of the good ones, of course, the preferred ones are the Oxford. I'm not promoting, I'm not a salesman for Oxford, but I found them to be good, so I'm telling you. Now, stand by for answers in the next slide. After you have done this, then go to the next slide and get your answers. And these answers I'll show you only for 10 seconds and then switch off. I don't want you to note down these answers now. Note them later on once you have done the numericals. So today, for the time being, having understood the concept of numericals, I'm not gone too much into the theory. And please do all these numericals and don't forget to write your difficulties or what you would like me to improve in the comments, that would you like some other things to be included. Of course, not too much of theory I've included, that I'll be doing in separate series of theory lessons. Good luck, all the best. This is SK Booty here, stopping or signing off for the day, and happy landings.